All right, we're asking to be able to solve the following equations, and they're giving us multiple kinds of equations here. The first one, 5a, is a quadratic because it has an x squared. Now, the way it's set up already is kind of nice if you just want to complete the square. So, for example, I mean, obviously you can do it however you want. This would be really easy to factor, actually. So I'm going to go ahead and subtract 63. So x squared plus 2x minus 63 equals 0. And then check this out. What times what equals negative 63 and subtracts to give us 2? 7 and 9. The negative goes here. So we would get x minus 7, x plus 9 equals 0. And those two solutions would be positive 7 and negative 9. So that would be doing this by solve by factoring. I do just want to show you the other method just so you can see the option. And so I'm going to just do this up here and then erase it. But I have x squared plus 2x, let's leave some space, equals 63. And so if I wanted to do this by complete the square, I would take the b, divide it by 2, I'd get 1 squared. So I'd be adding 1 to both sides of the equation. That makes the x plus 1 squared factors equal to 64. We root both sides. We get x plus 1 equals plus or minus 8. Minus 1, we get x equals negative 1 plus 8. And x equals negative 1 minus 8. Oh, look, I just got the same two answers that I just got with the other method. Which method did you prefer? But just to show you, we can solve these sometimes with multiple methods, and you're going to want to choose the one that you're best at. Okay. Part B is the new absolute value equations we've been doing. So let's add 5 to both sides because we need to isolate the bars. It's not ready to split yet. Let's divide by 6. We get absolute value of x plus 2 equals 4. Now we're ready to split into x plus 2 equals positive 4 or x plus 2 equals negative 4 and solve for both solutions. And there they are, x equals 2 and negative 6. All right, the next one says specifically to use complete the square, and I'm putting a huge star on this one. This is very, very much like the one on your test. Hint. Okay, let's go divide out the 6. I'm going to get x squared plus 2x blank, like make space, and move that 47 over. Notice that I divided out a 6 of the first two terms and just moved the 47 to the side for now. Now I go do the b work on the new b. 2 divided by 2 is just 1. 1 squared is just 1. So we're going to add 1 and subtract 1 6 times. Why is it 6 times? Because of the 6 that we divided out right there. So here I go, 6 parentheses. What are going to be my perfect square factors there? And then 47 minus 6. This makes the x plus 1 squared factors because 1 times 1 equals 1. X times x equals x. Keep the same middle sign. Right here, we're going to get 47 minus 6 is 41. And that's going to be minusing 41 from both sides. We're going to be dividing by 6. We're going to get negative 41 over 6 equals x plus 1 squared. We're going to root both sides. X plus 1 is equal to this old yucky fraction. Minus 1 from both sides. We get negative 1 plus or minus I root 41 over 6. I want to pause on that one and go to Desmos for a second just so we can visualize like what the heck does that look like. 6x squared plus 12x plus 47. Like, where'd the graph go? It's way up here. It's got an I in it because it does not touch the x-axis. So it's this really skinny, a stretch of 6, right? So picture how skinny. It's going up 6 times as fast as the parent, and it's way up there, and it never touches the x-axis. So that's why we got this I in our answer, because it doesn't touch the x-axis. And notice it's got a -1 line of symmetry. So go look at this graph. See how it's going through a vertex of -1. Okay, so anyways, just to kind of visualize this, like what the heck does an answer like that look like on Desmos? It's good for you to see and visualize that it's something that doesn't touch the x-axis. All right, let's go do the last one. It doesn't say to solve by any particular method, but just looking at that huge number in front, I'm going full formula. I'm going to go negative. Hang on, I'm going to try to fit this in this small box. Let's see how this goes. Negative -6 plus or minus -6 squared minus 4 times 12 times 5 all over 2 times 12. So this is my A. This is my B. And this is my C. Okay. Let's simplify it. I get 6 in the front. I get 24 in the denominator. And I'm left with 36 minus 240. And let's grab a calculator and see how that's going to come out. 36 minus 240. That's giving me -204. Okay. I'm going to go down here for the 204, and I'm going to break that up. For sure, it can be divided by 2. It can also be divided by 4. So 4 goes in. I'm going to make that a 2 and a 2. Let me do this where there's a little bit more space. Hang on. So square root of 204. A 4 goes in 51 times. And a 4 can be broken down into 2 times 2. Now, the crazy thing about 51 is it's 17 times 3, which there's no more pairs to be made out of it. So we're literally going to leave the 51 still in there. So a 2 comes out and a root 51 stays in there. So check out this final answer for this one. 6 plus or minus 2 root 51 over 24. Final answer reduce is going to be 3 plus or minus root 51 over 12. Yikes. There's a full formula one for you with all the simplifying we sometimes need to do. So there's that answer right there. There's this answer from number C. There's this answer for B. And there's this answer for A. I'm just realizing that your practice test might have cut off these last 2 problems, so it's up to you. These would be really good ones to write on your toolkit. Whether you want to write these or not, do what you got to do.